All right. Hello, everyone. My name is Minko. I lead product and DevRel for Angular at Google. Today, in this presentation, Houssein, Jatin, and I are going to share with you more about the frameworks that we're using for web development at Google, and also how are we supporting these frameworks and the ecosystem outside of the company. So first, we're going to talk about an internal framework called Wiz that has been innovating in the web performance space for a while. For example, it powers Google search, and performance there is pretty critical. After that, we'll talk about Angular, which probably you're familiar with. And at the third part of the talk, we're going to cover how we are supporting these frameworks and external technologies as well in terms of web performance. Before that, just to set the stage, at Google, we have multiple groups that are interested in web development and the web platform overall. We have Chrome that has been pushing the web forward for a while now, just in different ways, web browser, web standards, and supporting web frameworks as well. We have Angular, that is a popular JavaScript framework. We have the Wiz team also, that has been being used in like all the billion user products of Google. So it has been really focused on performance for a while. And we have a couple of other groups. For example, Flutter Web is also interested in the web platform, making web applications available in the web browser. We have the Material team and others. Today, in this presentation, we're primarily going to focus on the story from the perspective of these first three teams. Now, without further ado, I want to pass it to Jatin, who's going to be talking about Wiz.
Hello, everybody. My name is Jatin. I'm an engineer at Google, and I work on the Wiz team. And I'm here to tell you a little bit more about this web framework. Wiz is used to make a lot of products at Google, among them Google Search, and also other stuff like Photos, the Play Store, and Google Drive, and so on. It's easy to tell if your favorite Google product uses Wiz. Just pull up the HTML of the page and look for one of these attributes: JS Action, JS Model, JS Controller, or JS Data. If you see one or more of these HTML attributes on the page, that means that application is using Wiz. It's used by thousands of developers inside Google every day, and billions of end users use products made by Wiz on a daily basis. So why does Wiz exist? The primary focus of Wiz is performance. Server-side rendering matters when you want to make a performant web application. And Wiz focuses heavily on making really fast server-side rendering happen. A lot of our users are on low-end constrained devices, which means the amount of JavaScript that is loaded and executed really matters. On a low-end device, you don't want to load like way too much JavaScript and have the device groaning on. And last, a lot of our users are also on really slow networks. And the number of round trips that you make in order to make your application work on such networks really matters. And so you want to really think through and minimize the number of round trips so that the end users have a performant application. So how does Wiz do these things? The performance story of Wiz has three foundations. The first one is fast initial render. Server-side rendering in Wiz, the way it works, as soon as the request comes in, the server will start streaming HTML back to the browser almost right away, like the static parts of the HTML, the header, and so on. The second one is stable rendering. Wiz applications use the HTML as canonical DOM, and they ensure that the CSS of the page is available above before any of the components render to avoid a flash of unstyled content. And that way, the page doesn't shift around once it finishes loading. And the last and possibly most interesting foundation is instant interactivity. Wiz applications, through a combination of event replay and extremely fine-grained JavaScript loading, provide an instant interactivity experience, not unlike the one that was described by Shai in the talk earlier today. So let's talk a little bit more about that last piece, instant interactivity. So I'm going to walk you through an unoptimized client-side rendered application first to try to describe like the problem. A user loads the phone, picks their phone, they load a URL and navigate to it. The server responds with some HTML, right? Not all of it, but some of it. And then the browser starts loading the CSS and all of the JavaScript required to run the application. And then the JavaScript starts running. And if you're lucky, all of the data that's required to render that application is fetched in a single round trip. And so worst case, 3 round trips later, you finally have a completely rendered page, and the user can see what they came to see. This can be pretty suboptimal if the network is quite slow. So Wiz tries to solve this by saying, what if we could return an interactive page in the first round trip? In fact, as the HTML starts streaming, if the network is particularly slow and the user interacts with the page before the stream is done, the page will still be responsive, even though it's incomplete. And let's say that the user doesn't immediately interact and the page finishes streaming, then the framework will load only the business logic that's actually required based on what was rendered on the screen. For any component that was not rendered on the screen, the business logic is not even loaded. And even when the business logic is loaded, it's not run eagerly. It is instantiated and executed only when required. So a foundation for all of this to work is the event replay system. When the page is streaming, the event handlers are not actually attached. So what we have in Wiz is a tiny library that we call JSAction that sits at the root of the page, and it's listening to all of the events. So as an example, consider this really simple hierarchy, right? The JS action is listening right there at the root on the body. The user taps on the button, and the browser's native bubbling kicks in. And so the event bubbles up, and then JS action can finally respond to it. The way JS action does that is it looks in the HTML for those attributes that I initially mentioned, JS action, JS controller. And so in this case, as it's looking, it finds an attribute on that button element called button controller. It loads the JavaScript chunk and just the dependencies of button controller if it's not already loaded yet. And if it's already loaded, it instantiates the button controller class and then calls a method on that class to actually have the event handler run. And what's important is because that is the point where we're running the event handler finally has a chance to respond and say whether the event should bubble or not. So we have a second synthetic bubble that happens. So any additional JS actions on the way can also wake up and respond. And so in this way, this event replay system ensures that even as the JavaScript for the event handlers are not there, the page is responding. And this is the foundation of instant interactivity. As you can imagine, because of this, the event binding syntax for any framework that wants to do something like this is pretty novel. And Wiz is no exception. This is an example of a client-only rendered component in just some framework that's using TSX, right? So you kind of have this function, handle click. You have to obviously load the code for that, because all of it is just in one function. And then you instantiate that function and actually attach it using something like onClick equals the name of the function, right? Logically, you can imagine that maybe under the hood, the framework's doing like add event listener, click, onClick, right? And so till that line of code executes, the button is not interactive. You could keep clicking on it, nothing would happen. And so after server-side rendering the HTML, you have to wait for the JavaScript to load. You have to wait for execution to get to that point. And then finally, the user can actually interact with the page. So this is what I'm calling an interactivity gap in this picture. So how big is that gap? It depends on the amount of JavaScript that we need to load. And that is the amount of JavaScript that's required to hydrate the page. Imagine if there was an if condition in the template, and the button was rendered only if that if condition was true. When you load the JavaScript, you're going to load the other branch of the if as well, even though it's not actually going to run on the client side during hydration. We ran this on the server. We know that button is the one that's going to be rendered. But on the client side, to hydrate it, we're still going to load the branch that led to the span. So you can imagine, maybe we should just lazy load that entire chunk, right? What if we did that, then we don't need to ship that. But that kind of falls apart when you have cascading control flow. Because now if you just keep lazy loading at every border that you have an if condition, you're going to have like a waterfall. And that's no good. So the answer to how much JavaScript we need, unfortunately, often ends up being all of the JavaScript in the application. And this is a lot of JavaScript. And so the interactivity gap can be pretty big. This is an example of a Wiz component that tries to do hybrid rendering. And this is the novel event binding syntax that I'm talking about. If you just look at brass tacks, all you want to do is say JS controller equals some name of the chunk that you want to load. This is like your entry point. And then JS action is just giving you some more information about what is the event that I'm interested in and what is the method that I should call. And with this information, you can have this event replay library actually load the button controller only if required. So you can imagine if the user doesn't even interact with the button, maybe you don't even load that business logic at all, thereby minimizing the amount of JavaScript that needs to run on those low-end devices. So the HTML kind of looks like this, and you have no interactivity gap. You do need to load the event handler to run it. This is not magic. However, the key point is there is no interactivity gap. So what that means is you can ensure that that you're not dropping any events on the client side. And the second thing, you don't load more JavaScript than is actually required. When you load the button controller, you're not actually loading any other controllers that are on the page. It's just that one thing that's required to respond to the event that the user actually triggered. So the foundation of the performance story of Wiz, fast initial rendering, stable rendering, and instant interactivity. These kind of map to core web vitals that my colleague Houssein is going to talk about in just a bit. So Wiz is a closed source framework. It's not open source. And because of its nature, it faces some pretty unique headwinds. And I just want to quickly talk about the 3 big challenges that we're facing and what we're doing to try to overcome them. The first one is that it's quite different from popular open source frameworks. So when developers join Google and they have to learn this weird event binding syntax, they kind of face a challenge. There's a ramp-up time. So to kind of meet this challenge, Wiz is becoming a little less opinionated. We're asking ourselves, what does it mean to build client-only components and provide a better developer experience if the user wants to build a component like a dialog that really only renders on the client? The second thing we're doing is we're trying to modernize our capabilities. As a 10-year-old framework, the age of the framework's really showing in the kinds of APIs that we have. And so we're working, for example, with the Angular team on creating a signals-based API to drive fine-grained updates and fine-grained code loading. Another challenge that Wiz has is the developer experience does not meet industry standards. Part of the reason is because Wiz does not do server-side rendering in JavaScript servers. Instead, we do server-side rendering in Java servers. And this means we kind of had a custom templating language that allowed us to do that. To make the authoring format more relatable, Wiz is currently exploring using TSX as an authoring format while continuing to have the constraint that we should render in Java servers. And so that's a pretty unique challenge, and we believe if we can solve that, the resulting authoring format would be something that's very relatable to developers who've already been developing in the open source. And lastly, even though Google is a really big company, the size of the Wiz community inside Google is pretty limited. And so when you run into trouble, it's hard to debug, and it's hard to find help when you need it. Googlers, when they are building Google Search, cannot use Google Search to solve their problems when they have a problem. And so they have to depend on this internal community. So we're trying to do 2 things. We're trying to increase the size of this internal community. We're hoping that if we become less opinionated, more developers inside Google will use Wiz, and the size of the community will grow. And the second, we recognize that if we want to depend on the ecosystem outside, we have to start participating in it. Luckily, we have a lot of experience in that area. And to talk more about Angular, I want to call Minko back on the stage. Thank you. All right.
All right. Yeah, so Angular is the other popular framework at Google that is used by thousands of applications inside of Google. For example, Google Cloud. We have maybe about 14, 15 million lines of Angular specifically in Google Cloud Console, so it's a pretty big application. Also, externally, it has been used by KLM, Vanguard, Fidelity, and also some startups, for example, ClickUp, SpaceX, and others. One interesting thing about Angular is that it kind of bridges the gap between these 2 worlds, between Google and the external world. And we're in a good position to offer some inspiration for Googlers with some ideas from the external world and also make some Google ideas open source. So historically, Angular and Wiz have been serving different application segments inside of Google, like Angular has been very much used for highly interactive applications. I already mentioned Google Cloud Console, Google Analytics, and others, where you have a lot of data visualization or forms. And Wiz has been used for very performance-focused apps, where you want to deliver your first byte as quickly as possible and load your JavaScript and make it as minimal as possible as well. However, over time, we see that these two worlds are kind of blending together. The more static applications, they keep adding more functionality, and their developer experience requirements increase. And the highly interactive applications, well, they have already a lot of JavaScript. And JavaScript is one of the reasons for our applications being slow, so we need to figure that out too. So we have been having I'm going to talk actually about two main areas of inspiration that Angular and Wiz have been working on together and has been driving from each other. The first one is around signals. So Angular introduced the Signals API, where we can pretty much declare a signal inside of an Angular component. We wrap this primitive world value as a signal. And the Angular template is going to end up getting compiled to JavaScript. So when we read the signal, signals have this great property to let us know in which function the signal was read. So when we update the signal, we can very easily go to the specific part of the template and update the minimum amount of UI, which is great. Angular didn't invent signals. They have been around for a while. For example, Vue, React has signals. And also, specifically on our signals library, we worked closely with Ryan so that we can learn from his experience. So thanks, Ryan. Another idea that we have been collaborating on with the Wiz team is around deferred code loading. You learned about JS Action, and you learned about the very finely grained code loading that Wiz has. That is very implicit there in Wiz, so it is lazy loading by default. And we worked on a primitive for Angular that makes it a little bit more explicit so that it can better fit the current state of Angular itself. So with deferred loading here, we can specify that we would like to deferredly load the list component, specifically when the placeholder enters the viewport. And this handles all the complexity around managing intersection observers and also loading states and much more. Traditionally, when we're doing server-side rendering, we would render the application on the server, and we're going to deliver the rendered HTML to the client. The browser is going to parse it, create the DOM, render it, fetch all the JavaScript, and hydrate. With the Aurora team, from Houssein is going to share more about it, we worked on full app non-destructive hydration in Angular, and this is how very commonly frameworks work nowadays. One problem is that if you have a lot of JavaScript, things can get pretty tricky. This could be a pretty slow process. So something that we have been exploring is partial hydration that uses a concept very similar to JS Action. Now imagine you render the application, and you get just static HTML with very small piece of JavaScript with JS Action without loading your application at all here. When the user engages with any particular component, we can figure out which component they engaged with. We can download only this particular component and hydrate only this part of the UI and make it interactive. This way, you have way less JavaScript to load, and this improves your core web vitals significantly. Additionally, we can replay the event so that we don't lose it. All right, these are some of the features that Angular shipped lately. We additionally are working on fine-grained reactivity with these signals. We have Vite that, together with ESBuild, improved our build time with server-side rendering about 87% or so, and refreshed documentation and learning journey. So with this, we're feeling that we're entering kind of a new era for Angular. And actually, the community has been calling it the Renaissance. We want us to reflect that in the Angular's identity as well. So a couple of months ago, we refreshed the logo to make it a little bit more aligned with where Angular is heading. If you're interested, go check angular.dev. That's our new documentation website. All right, now I would like to pass it to Houssein, who's going to share more about how Google is supporting web frameworks in and outside of Google.
Thanks, Minko. Yeah, my name is Houssein Djirdeh. I am a software engineer on the Chrome Aurora team. And I'd love to continue where Minko left off to talk about how we collaborate with Angular, but with other JavaScript frameworks in the ecosystem as well. Aurora is the name of the very small team and initiative in Google Chrome that collaborates with open source frameworks and tools. The reason we do this is because we know that to make an impact across the web, we have to invest in improving the tools that millions of developers rely on and make them better and faster. In both Minko and Jatin sections of the talk, I'm sure you all have noticed that many developers face very similar challenges, regardless of what framework they use. Things like, what rendering strategy should we use? How do we load the right fonts and scripts in the right way? How to optimize video and images? How to even host your application? And the list goes on and on. Generally, we recommend a lot of different approaches to developers on how to handle these challenges, like you should partial render, or you should chunk your JavaScript, and so forth. But what if frameworks as a whole could do all of this automatically? One of the features that we worked with the Angular team was the ng-optimized image directive. And the idea here is, with all the research we've done and a lot of the local lab experiments we've done in the past, we've seen how much of an impact poorly optimized images can make on the web. So if you're an Angular developer, what if there was a directive that you could use that will automatically optimize the image for you? And that's the idea behind this specific directive. The nice thing about baking these type of features into an API like this is that we can also add other additional opt-in features. You want to actually prioritize a certain image because it's above your device fold, there's a priority attribute for that. And that'll signal to Angular to include the HTML fetch priority attributes and a preload tag on the server. So images are one thing that affects core vitals. But like I mentioned earlier, there's a lot of other things as well, right? Fonts, third parties, rendering, and there's a whole list of things. The way we try to approach things in the Aurora team is we try to identify what the biggest issues are across the web, and then see if we can find some specific useful features and then bake them into the frameworks themselves. Minko mentioned this as well, but we also collaborated with the Angular team on full-page non-destructive hydration. And the idea is we wanted to see if Angular could, instead of destroying and recreating the DOM every time it hydrates, what if it could use existing DOM nodes where possible? We helped them launch this feature, and applications that switched to server-side rendering with non-destructive hydration saw a 200 millisecond improvement in LCP, or largest contentful paint. This is between the 60th and 80th percentiles, but this is a pretty big win. And outside of just Angular, we've also collaborated with other frameworks as well. We also worked with the Next.js team to launch a very similar image component. If you're using Next.js and you want to have optimized images out of the box, import and use the image component, and automatically your images will be optimized, regardless if you're fetching a remote image or a local image. And again, the same idea happens here. We give a good default experience, but for specific use cases like, hey, I want to prioritize a certain image, there's a prop for that. And now I'm sure you all are starting to see a pattern. We also worked with the Nux team to launch something very similar. If you're using Nux, but you want to make sure all the images are optimized as fast as possible, make sure you install the Nux image module. And again, it'll do everything it can right out of the box. But if you want to specify additional things like I want to load certain images eagerly versus lazily, there's attributes for that as well. Another thing we've been quite invested in for the past year or so, and a part of work that I am actually very invested in personally, is how can frameworks optimize third-party scripts that any developer decides to inject? The tricky thing about third-party scripts is it's hard to optimize code that the developer isn't writing. So one thing that we rolled out for the Next.js framework was a component where instead of using the regular HTML script tag, you can automatically use this. The syntax is almost the same. And what it will do is it will load the third-party scripts after all the initial Next.js first-party chunks have been fetched. And we've also tried baking in more useful features that are more specific. If you wanted to delay the load of third-party scripts until browser idle time, you can use the strategy property and define a value of lazy on load. One thing that I'm actually working on now is extending this even further. One thing we've noticed is that a lot of developers using the script component are still kind of confused on what strategy to prop to use depending on the third party. So we decided, what if we built a higher level library, even though opt-in, that developers could use that will automatically optimize popular third parties? For example, using a YouTube embed. This is still experimental, and it's an opt-in library that you have to install, but it's only been out for a couple of months, and it has about 800,000 downloads. So a lot of developers are starting to see the use of this as well. We're also working with the Nux team right now on something very similar. Could there be composables and useful components that, when used, can automatically optimize popular third parties, like Google Analytics? The nice thing about this is we're using some neat lower-level Vue and Nux APIs to actually make some functionality easier. For example, waiting for the script to load to send a custom event. So all the things that I shared is just a glimpse of everything that we worked on. But one thing that I want to highlight is, for all the features that we bake in, we're trying to see if we can share the best ideas cross-framework. Because regardless of what framework you're using, these are all issues you're going to have to deal with on a daily basis. Hope you enjoyed this talk as much as we enjoyed giving it. Thank you.